Hearty welcome to You Too Can, a channel that will help you to succeed in examinations easily.
So let us do a problem in RLC series circuit excited by a DC voltage source. Okay, let's read the problem. A series RLC circuit has resistance of 50 ohm, inductance of 0.2 Henry and capacitance of 50 microfarad. A constant voltage of 100 volt is impressed upon the circuit at t equal to 0. You have to find the expression for transient current assuming initially relaxed conditions. Here it is given as initially relaxed condition. What is the initially relaxed condition? The current through the inductor is taken as 0 and the voltage across the capacitor, that is 1 by C minus infinity 0 I of t dt, will be taken as 0, and you have to derive the equation for transient currents. As you all know, an RLC series circuit, when it is excited by a DC voltage, it will have three cases depending upon the types of roots we have. Okay, so first you have to check whether it is an underdamped or overdamped or a critically damped, then proceed to do this problem. Okay, so first let us draw the circuit. That is a resistor of 50 ohm, an inductor of 0.2 Henry and a capacitance of 50 microfarad is impressed by a DC voltage of 100 volt. The switch is closed at time t equal to 0. So you have to write the initial KVL equations and solve it. Okay. So before that you have to find the case, whether it is an underdamped or overdamped or critically damped case. So for that you have to find the values of R by 2L the whole squared. You have to remember this, R by 2L the whole squared and 1 by LC. You have to remember this formula, 1 by LC, R by 2L the whole square. What is R by 2L the whole square? 50 divided by 2 into 0.2 the whole square. So 50 divided by 2 into 0.2 will be 125 the whole square, that is 15,625. This is 15,625 the values. Here 1 by LC. 1 by LC is 1 by 0.2 into 50 into 10 power minus 6. Okay. 1 divided by 0.2 into 50 exponential minus 6. This will be 1 into 10 power 5. Okay. So here R by 12 the whole squared is 15,625. 1 by LC is 1 into 10 power 5. Compare the values of 2. Which is greater? R by 12 the whole squared is lesser than this. That is R by 12 the whole squared is lesser than 1 by LC. What is this condition? This condition is called underdamped condition. Underdamped. This less means it is underdamped condition. So what will be the roots? The roots will be complex conjugates. Okay. So the output will be oscillatory. Okay, complex conjugates. So first you have to find this, compare this and find whether it is underdamped, overdamped and critically damped, then proceed. If it is an underdamped, I am going to derive a method which you have already seen in your max also. So you can follow the same method for underdamped cases. Okay, now let us see the problem. Now write the KVL equations for this. So the KVL equation is 50 I of t plus L di by dt. So 0.2 di of t by dt plus the initial voltage of the capacitor is already taken as 0. So we can directly write it as 1 by 50 into 10 power minus 6. That is interval between 0 to t alone I am writing I of t dt will be equal to the supply voltage 100. Okay, now take Laplace. Now 50 I of s plus 0.2 for di by dt, s I of s minus I of 0 plus 1 by 50 into 10 power minus 6. Okay, so 1 divided by 50 exponential minus 6 is taken as 20,000. Okay, 20,000, that is 2 into 10 power 4. I of t will become I of s by s. It will be equal to 100 by s. Okay, here this initial condition of I of 0 is taken as 0. So 50 I of s plus 0.2 s I of s plus 2 into 10 power 4 I of s by s will be equal to 100 by s. Okay, take I of s common. I of s into 50 plus 0.2s plus 2 into 10 power 4 by s will be equal to 100 by s. So take LCM. 50s plus 0.2 s squared plus 2 into 10 power 4 divided by s equal to 100 by s. Okay. Here s gets cancelled. So I of s is equal to 100 divided by 50s plus 0.2 s squared plus 2 into 10 power 4. Okay. Now arrange this denominator in an order. So 100 divided by 0.2 s squared plus 50s plus 2 into 10 power 4. That is s squared, s term and constant term. So take the coefficient of s squared outside, that is 0.2 into s squared plus 50 by 0.2 s plus 2 into 10 power 4 by 0.2. That is, what is 100 by 0.2? 100 divided by 0.2 will be 500 divided by s squared plus, what is 50 divided by 0.2? 50 by 0.2 will be 250s, and what is 2 exponential 4 divided by 0.2? That will be 1 into 10 power 5. So 10 power 5. Now this is I of s. Here we have already known that the roots are complex conjugates. So no need to find the roots again here. Okay. And here there is one method I am telling you. Here you have to see what is the coefficient of s. What is the coefficient of s? S is 250. So consider this 250 and divide this by 2. What will you get? 250 by 2 will be 125. If the roots are complex conjugates, you have to find in this manner. Okay. Here you have to add 125 squared and subtract 125 squared from this equation. This is the procedure. Just follow this. Okay, so take down 500 divided by s squared plus 250s plus 10 power 5 plus you have to add 125 square minus 125 squared. I will repeat it again. Here the roots are complex conjugates. Roots are complex conjugates, that is underdamped. After you have identified that this case is underdamped, then you have to proceed like this. Okay. Here the coefficient of s is 250. You have to divide 250 by 2, you will get 125. You have to add 125 squared and subtract minus 125 squared. Okay. Now take this as common, that is 500 divided by s squared plus 250s plus 125 squared plus 10 power 5 minus 125 square. Okay, so you can write it as s squared plus 250s plus 125 squared. We can write it as s plus 125 the whole square. Okay, s plus 125 the whole square means s square plus 125 square plus 2 into 125 250s. Then write this separately, that is 1 exponential 5 minus 125 square, which will be 84375. It is 84375. Okay, so you have to find the square root of this. Okay, square root of this is 290.5. So square root of this is 290.5. So we can write this 84,375 as 290.5 the whole square. So I of s is equal to 500 divided by s plus 125 the whole square plus 290.5 square. Okay, now we have to take Laplace inverse for this. We have already known a formula, that is Laplace inverse of omega by s plus a the whole squared plus omega squared. It will be, that is something by s squared plus omega squared will be sin omega t. But here instead of s we are having s plus a, so it will be e power minus at sin omega t. So Laplace inverse of omega by s plus a the whole square plus omega squared is e power minus at sin omega t. Okay, but we can apply this for this condition. But see this, here it is s plus a the whole square plus 290.5 square, but in the numerator we will have 500. So if this 290.5 is in the numerator, we can write it like this. Okay, so we have to change as I of s is equal to multiply and divide by 290.5 in both the numerator and denominator, so that the value is unchanged. So s plus 125 squared plus 290.5 squared. Okay, here we are multiplying and dividing the equation by 290.5. Now this 290.5 by s plus 125 the whole square, this will be like this. That is omega by s plus a the whole square plus omega square. So we can write this as e power minus at sin omega t. Now what is the value of 500 by 290.5? 1.72. So this is 1.72 into 290.5 divided by s plus 125 the whole square plus 290.5 squared. So this is I of s. So after taking Laplace inverse, I of t will be 1.72 into the Laplace inverse of this will be like this. So e power s plus a, instead of s plus a we have s plus 125. So e power minus 125t, and instead of omega we have 290.5, that is sin 290.5t. Hope you have understood this problem. Thank you.
Queries? Please feel free to ask your doubts and clarifications in the comments section. Thanks for watching this video. Wish you all the best. Please subscribe this channel for more updates. Thank you.